All right, hello everybody. Since Ariz didn't want to introduce us, I guess I'll have to do it myself. My name is Dr. Connell Miller. I am a professor over at Western University, as well as the director of the Northern MESNET project, and more importantly for today, the coordinator for the Canadian Sphere Storms Laboratory Summer Internships. With me, I have Aaron Jaffe, who's the engineering researcher and basically the field coordinator for the Northern Tornadoes project, and Jack Hamilton, who some of you may know, as he's, I believe, just finished some courses here at York, who is the field coordinator for the Northern Hail Project. We're here today to talk about not only the summer internships, but Rees asked us to talk about a case study that CSSL worked on over the past year. So we'll be talking about the Enderlin EF5 tornado that occurred. So we'll do the summer internship stuff first. Aaron and Jack will talk about that. We'll do a brief Q&A if you guys have any questions about any of the internship stuff, and then I'll come back and do some of the Enderlin stuff. So I'll pass it over to Aaron to start us off.
Thanks, guys. Just for my own curiosity, who was here at this presentation last year? Raise your hand. Okay, it's not everyone, only half or so. Okay, so a lot of this will be repeat information if you've seen this before, but for some of you it'll be new, and for those that have seen it before, hopefully it interests you enough that you'll learn something you didn't last year. So yeah, as Connell said, my name is Aaron Jaffe. My background is in structural engineering. So I did my undergrad in civil at Western and then my master's in wind engineering. And then I've been working for the Northern Tornadoes Project since about 2018. And then I've been involved with the summer interns here for the past few years, mostly leading the tornado field interns out of Western. So that's my position. That's my background. This presentation, as Colin kind of outlined, we'll start with some talk about CSSL. Then we'll dive into NTP, the Northern Tornadoes Project. I think some people or most people know the acronyms, but maybe I should also spell them out. Then we'll talk about NHP, the Northern Hail Project, Northern Mesonet Project, NMP, follow that by some internship info, and then end it off with the Enderlin stuff, which no one will have seen before for the most part, because that's pretty brand new. So without further ado, that's a photo of the Didsbury tornado, which I'm sure almost everyone here recognizes. So obviously severe convective storms, one of the most common and damaging natural phenomenon in Canada. Everyone here knows that. They produce many hazards, winds, precipitation, including hail and flash flooding, and also lightning. So why do these matter so much? Well, the losses are on the rise exponentially. It's getting worse year to year, and this is far beyond anything like just a trend from inflation or something, right? So just in 2024, I don't even know if this is the final number, but $8 billion in losses and that's not including all the losses that weren't insured, right? These are just the losses that they could count easily. And that's from a lot of things: population growth, rising property value, effects of climate change. There's a lot that goes into that, but the important part is that we need more research, we need more people working on these problems to come up with solutions and to help mitigate this. If we look at the 10 worst, I think it's the 10 worst natural disasters that occurred in Canada in the last 20 years, you'll notice that 5 of them are from severe convective storms, and 6 of them happened in just the last few years, 2022 onwards, right? So a lot of events that I'm sure you'll recognize on here, from the derecho that happened back in 2022 to the major flooding event that affected the GTA in 2024, to the Calgary hailstorm that also happened in 24 and is, I guess, Canada's second costliest, natural disaster ever. So obviously pretty bad. And so for that reason, this all came together into the Canadian Severe Storms Lab that was officially launched in 2024. So it's a combination of the Northern Tornadoes Project, which was established in 2017, the Hail Project in 2022, the Northern Mesonet Project run by Dr. Connell Miller in 2024. And that's all put together now, to basically be the, authoritative source of, all this data collection, all this information in Canada. And, at the end of the day, we're trying to, predict these storms better. We're trying to prepare for them better. And to do that, we need to fully understand what's happening. And so just kind of a simplified, pipeline here. You have observations from the Northern Ed Mesonet project, as well as, wind observations and hail observations from the tornado and hail projects. And all that is going together to produce things like climatologies, research databases, et cetera. All those things that we need to achieve all of the goals that we're aiming for. So that was kind of the CSSL intro. I'm now going to talk about the Northern Tornadoes Project specifically. We will have lots of time for questions both after each section and at the end. So you're welcome to save your questions for then in case it gets answered. But also, if someone wants to ask something while I'm presenting, that's okay too. Just raise your hand. It's not a problem. So this is a video of the Didsbury EF4 that affected not too far from Olds. And this video, although it's the start of the Northern Tornadoes Project section, this video is actually captured and seen by the Northern Hail Project team because they were the ones that were out there. So that would have been, I'm a little bit jealous. That would have been very, scary, but also cool to have seen. And so, what is a tornado? I think everyone here knows this, but basically, violently rotating column of air that's connected to both the cloud base and the ground. Those are the important elements. If it's only connected to one of those things, then it might be a funnel cloud or it might be a dust devil, something else that's commonly mistaken for a tornado. Now, although we're called the Northern Tornadoes Project, we also do a lot of work on other severe wind events that come from convective storms. The most notable one otherwise would be downbursts. So downburst, as many of you probably know, is another type of wind event that can also cause concentrated severe wind damage. But it's usually over a wider area, and there's some other things and patterns that you look for that differentiate them from tornadoes. Where do tornadoes occur in Canada? So from 1980 to 2009, a climatology was done that showed that Canada got about 60 tornadoes per year. But the problem was that there was these, studies that had been done that, modeled where tornadoes should be occurring based on things like lightning data that were showing, well, actually Canada should be getting at least 150 tornadoes per year. That's obviously a huge difference. And, if you overlay those two things, these gray areas showing where you should be getting tornadoes, the dots are showing all the tornado reports. Obviously, we have all these areas, the prairies, northwestern Ontario, eastern northern Ontario to southern Quebec, all these areas where we should be getting tornadoes, we're not. And probably a lot of you know this is a population density problem, right? If nobody lives there, the tornado doesn't get reported, it doesn't get documented. And a question that you might ask or others might ask is, well, why do we care about these tornadoes if they're impacting areas where nobody lives? But if we want to actually understand tornadoes and predict them, we have to be documenting all of the tornadoes that Canada gets, not just the smaller portion that affects populated areas. Not to mention population centers are constantly shifting, right? Somewhere that was, sparsely populated in, the 80s when this climatology started might not be sparsely populated now, might not be sparsely populated 20, 30 years from now. And so with that, the project goals, kind of modeling after the goals of the CSSL as a whole, are to capture data about every tornado in Canada, improve our methods for detection of these tornadoes, influence public awareness, building practices, try to improve, although we don't do them directly, try to help, like Environment Canada with tornado warnings, for example. So there's a lot that can be done with really good data collection, which is what we're aiming for here. Raise your hand if you're familiar with the Enhanced Fujita scale, the EF scale. Everyone. Okay, basically everyone. Okay, I'm not going to go into it then. But as you all know, that's how tornadoes are rated in North America. EF0 to EF5. EF0 by far the most common, least destructive. EF5 the most destructive. But the key thing is that these wind speeds aren't measured directly. They're, of course, estimated based on the damage, right, to various damage indicators. So those damage indicators could be anything from trees to houses to barns. And so when we go out in the field, this is the damage indicator for houses, for example. This is a house that was unfortunately destroyed in the Didsbury EF4 tornado. And this is a simplified case. There was, I think the decision was a little more stressful than how I'm showing it here. Connell can attest to that. But I was on vacation for this because I'm on vacation for every EF4 that Canada gets. I think that's the real way we should be modeling strong tornadoes in Canada. But so in this case, all walls collapsed. That would get you an expected wind speed as long as the house is built adequately, 275 kilometers an hour, which would be an EF4. And then those are the exact numbers you'll see if you read the news articles afterwards. And I think something that's really satisfying, I'm speaking mostly towards the tornado field interns because those are the ones I work with, but it applies to all of them. It's something that's really satisfying is, they're the ones that are going out, with me or someone else in the field collecting all this information. Then, they see it in the news next day. It's like, it's not just like random numbers they're spitting out, right? Like they were actually on the team that helped come up with that. So I think that's really gratifying for them. So I want to talk about a few of the different ways that NTP collects data. This isn't all of them, but this is kind of some of the main ones here: ground surveys, satellite surveys, aircraft surveys, and drone surveys. So starting with satellite's a really big part of what we do because there's so many of our tornadoes, like we just talked about, that occur in these rural areas where there's, no really other good way to document them, right? But thankfully, because so much of Canada is forested, the tornadoes that are at least EF1 or so in level will almost always leave this scar through the forest that you can find looking at before and after satellite imagery. So just to show a quick example of that, this is the tornado from Actinolite, which is near Tweed, or if you don't know where that is, it's near Belleville, Ontario. And very clearly, if you flip between the before and after imagery, you can see the huge tornado track that went through here. This was actually Canada's longest tornado since, I want to say, maybe 2008 or so. Maybe someone knows those numbers better than me, but that's my memory. It was about that. So 56 kilometers, pretty significant. And so you can see that satellite is totally invaluable in, assessing these and documenting them. And there's a lot that we can do with that satellite imagery just beyond finding each of those new tornadoes. So a few of these are previous research intern projects. So we have things like looking historically for tornadoes. So NTP went back and found a lot of the tornadoes, many of them that were missed over the years when we weren't doing this and when satellite wasn't really being used to find these tornadoes. But you can go back several decades to since we've had good satellite imagery to find these. So we've really improved the past climatology as well as the current climatology for tornadoes. We also had one of our great interns has now turned this into a we turned both of these into papers actually. NDVI analysis of how the tornadoes have affected croplands and fields as they've gone through in areas that we don't have trees, or using synthetic aperture radar analysis as well. You can also see that strong tornadoes will show up there. So there's a lot of different things that we can do with this satellite imagery beyond just looking for those tornado scars in the forest. Moving on to, we've always called these aerial surveys. We're trying to transition that to aircraft surveys because aerial can technically refer to drone as well. But our aircraft surveys here, these aren't used as often these days just because the drone technology is getting so good that, aircraft surveys, they're very expensive. But if you need really good high quality data in a remote area, we still do these sometimes. And a lot of what I'm going to say for these aircraft surveys can also be applied to some of our drone surveys. This was aircraft imagery from, I don't have the other photo I was looking for. That's okay. I didn't outline it here like I wanted to. It comes in on a slide later, but all this area that's kind of grayed out that you can see along the middle here, that's actually Canada's widest tornado ever. So Brooks Lake happened in 2020, sort of near Kenora and Dryden, Ontario. That's really the only cities that anyone would recognize around that area. Thankfully, this was in the middle of nowhere. I don't want to think about what this would have looked like through a populated area, but this was a very significant event. And events like these allow us to use some of our more advanced methods rather than, it used to be me or one of my coworkers would be looking through this imagery and, highlighting all the areas where there was damage and, marking down the directions of either areas of trees or sometimes even individual trees, which takes a really long time. But thanks to some of the great interns we've now had just this last year, one of our interns worked on a model that automatically looked at, okay, where are the areas of damage? So the red areas here, where are the areas of upright trees, the green areas, and where are the areas of anything else, basically those yellow areas. So that's really helpful to, I really wish we had something like that, 5-8 years ago when I was doing a lot of these things manually. But that's been a really big help. And then also for tree directions, one of our former interns, now PhD student, Daniel Butt, worked on this one, and he looked at, using AI, convolutional neural network, to look at, the tree directions, get a direction for every tree, average them out so that we can get a better understanding of what the directions looked like for that event. We can do a few things with this beyond it just looking pretty cool. If you're, into tornadoes and wind patterns like I am, this is also helpful for doing things like properly estimating the wind speeds that were in that tornado. So an issue we have with these forested tornadoes is if an EF2 goes through the forest over the Canadian Shield, it basically takes out every tree. If an EF5 tornado goes through, it basically takes out every tree. So just using the EF scale, we can't actually accurately assess what the wind speeds were. But one thing we can do with some of our advanced methods, including the tree fall model and the debris model, which Connell's going to mention later, is we can, have these other advanced methods of estimating what the wind speeds were. So there's things you can look for in the patterns to tell you, okay, actually this tornado was, beyond EF2. So that's been really helpful, and being able to do some of this stuff automatically, obviously makes it more feasible to do it on more events. Drone surveys, so similar to aircraft surveys, of course, except in this case, it's actually our team going out there and taking the drone imagery. So it can't be a fully remote area here. It has to be an area that we can at least access somewhat by car. But drones have totally changed. I mean, changed how we do surveys, although we've had them since close to the start of NTP, but changed how, researchers as a whole are doing surveys for sure. Now we can get, these really good images of tornado paths. This is one that you can actually see it going towards this barn in Belmont, Ontario, near London. Unfortunately, took out the barn and then continue onto the field afterwards. It's really useful just for finding, the start and end points, getting a better view of where to survey next. Access, mostly inaccessible areas. This is along the Ottawa River, heavily forested area with lots of water. There's no way we're going to be able to walk across all of this. So the drone is really useful here for getting, proper images of what the damage looks like. And just for getting, photos that we wouldn't otherwise, better views of structural damage, close-ups of structural connections. These are photos from the Alonza, Manitoba EF4 that happened back in 2018. So this is one of 2 EF4 tornadoes that's occurred since NTP started, for those interested. And we can take, of course, just great videos like this one that are, these are, they can be used for research, but I think more so these are great for presentations and media and things like that. So this is a really massive tornado track that went through Buffalo Lake, Alberta, which is a few hours northeast of Edmonton there. So probably one of the better drone videos I've taken in my day. And these are the surprises of surveying, especially even now, but especially back then. Like, you would just get reports of tree damage and you wouldn't know what to expect. Sometimes you'd go out and there'd be, a farmer with maybe 2 trees down on their property, and that was your report of tree damage. And sometimes you'd pop the drone up and you'd find a 15-kilometer long, 1-kilometer wide tornado track. So until the satellite comes out, you sometimes don't know exactly what you're going to get. Another thing we can do with drones that I don't have time to get into more is orthomosaic mapping. So kind of like we do for aerial, we can use our bigger fixed wing drones to map out an area. So what I'm doing here is, this is the satellite imagery of the worst damaged area in Didsbury, and this is the drone map afterwards. So you can obviously see the really big difference between what it looked like and unfortunately how heavily it was devastated after the EF4 tornado went through. And so those drone maps are so useful for just like, capturing all the data in a known area where you have damage, and you can do things like, go back and assess anything within that path. You can measure distances. You can do all sorts of things that you wouldn't be able to anywhere near as easily with just individual drone photos or, let alone a ground survey. Finally, we have ground surveys, which go hand in hand with the drone surveys, but here I'm talking about actually, being on the ground. This is, the ground and drone surveys are obviously, if you're interested in a field tornado internship with CSSL, that'll be mostly what you're doing, the ground surveys and the drone surveys. The satellite and aerial, although still relevant, it's a little more relevant to potential research interns. And so this is actually, us, going out into the field. There's a Reese. And, documenting the damage, taking photos, taking notes, talking to homeowners, the old way that surveys have been done, and still a much needed part of our surveys today. And, why do we do these surveys, right? So the goal is to, obtain comprehensive field data to help, rate and classify those events. And of course, this is much higher quality data than, relying on social media posts or satellite or those other things that we have to do when a ground survey isn't possible. And it's obviously a lot more cost effective than other high resolution methods like an aerial aircraft survey, for example. Oh, there's a photo. I got a photo of all of us in there. Oh, look at that. Oh, that was just an accident. And then, just a little bit about, I feel like we get lots of questions about this, so I added some slides on kind of the survey team organization. So this mostly applies to the NTP field team, but pieces of it apply to the Hail team as well. But we have a survey director, survey lead, and the surveyors. So the survey lead would be someone like me who's leading the team out there in the field. The survey director is usually the director of NTP, Dave Sills, although sometimes it's someone stepping in for him like Connell or someone else. And they're the ones that are kind of, back at Western or back at base, kind of making the major decisions and handling most of the media requests. And then our surveyors are, mostly interns like you guys who are doing a great job helping us collect data, drive the vehicles, talk to homeowners, and do all those really important tasks. And so typical survey could be anywhere from 2 to 5 members, depending on the severity and how many people are available. And in really big events, we might send out multiple teams. And we have, kind of 3 main teams across Canada here. So we've got our team based at Western, our team based at the University of Manitoba, and our team based at Olds. So if there's a wind event in, these are all kind of like loosely speaking the jurisdictions of each of those teams, which is basically just a map of everywhere that's within like a 10-hour drive or so. Because if it gets outside of that, then we start thinking about flying into that red area, which is usually the London team that will do that. But yeah, so the Olds team, the Hail team will handle most wind events that were within that area. The London team will, of course, handle everything in the purple, but also the red. And then we do have a team at the University of Manitoba. If you're applying as a tornado field intern, unless you're from the University of Manitoba or from Manitoba in general, we just kind of assume that you're applying to work at Western. But if you would prefer to work in Winnipeg for some reason, then you are welcome to let us know that.
We can't say that.
No, Winnipeg's lovely. That's why I've only been for surveys. And then we have a rotating schedule of survey leads and surveyors. So you'll know when you're more likely to be out on a survey. And through all this work, we're filling in the gaps of our knowledge. So, this is those circled areas in the old climatology. And if I circle those same areas in the new climatology, you can see that we're really starting to fill in tornadoes in all those areas, especially in Ontario and Quebec. And that's not because we're, just magically getting tornadoes there now. It's because we're, actually starting to document and find those tornadoes, which has been awesome. And yeah, that's the end of my section. There'll be a chance to ask questions on anything at the end, especially the internship stuff. But before I hand it over to Jack, does anyone have anything they want to ask now? Yeah.
Northern Hail Project, people will also do tornado like wind surveys as well.
Yes.
Yeah. So Jack will touch on it a little bit more. But the Hail team has 3 teams out there. The Hail team split up into 3 separate teams of 3 or 4 or so. There's a lot of teams within teams. It's very confusing. We have charts. But yeah. But one of those teams is the damage survey team, and they're responsible for any kind of damage survey. So it could be a hail damage survey, it could be a wind damage survey. In theory, it could be like a flood damage survey. And so yeah, so they'll if something really big happens in Alberta, the London team will often still fly out. So for example, when the Didsbury event happened, back then Jack was he was still on the light side. He was still a tornado intern with me. And so him and I think it was him and Aries. Was it you two that flew out there to help out the Hail team? But for most wind events out there, the Hail team will just survey them. Yeah. Any other questions before we move on? Great. We will move on to Jack then to talk about the Hail project.
Thank you, Aaron. I'm going to take a sip of water first. Aaron gave a nice introduction to the damage survey team, so I can go quickly through that section maybe. All right, so I'm going to talk about mostly the same things that Aaron talked about for the NTP, but on the NHP side, being the Northern Hail Project. You may have heard of the last dedicated hail field program in Canada. That was the Alberta Hail Project that ended in 1985. And since then, we haven't really had any quality research done specifically on hail in Canada. And that's left us with a gap in high resolution data on hail and hailstorm occurrences. And it's been a bottleneck in advancing our research, especially in forecasting and that sort of thing. So that's the reason why the NHP started, and the reason why we have our dedicated field program is to advance our data collection and our understanding of hail, especially in Canada. So one of the main ways that we do this is through our field operations. So since 2022, the NHP field team has been out in Alberta capturing data on hail occurrence in the Alberta foothills. And usually we have about a maximum a team of 12 that kind of fluctuates year over year. And like Aaron said, we're in Olds, Alberta, which is on the map here, the yellow dot between Calgary and Red Deer, right kind of in the middle. And our area that we cover is the yellow outline generally, but we can go beyond that. Last year we went into Saskatchewan at the end of the season, so we can go beyond that, but generally that's where we operate. And the reason why we're successful here is because Alberta gets so much hail, we can actually essentially study it like it's a laboratory study, but it's the real world. We can, what our field operations team does is chase after these hailstorms, collect the hail that falls right in behind them, gather the data from the storms themselves. And that gives us a really nice picture of how hail is occurring in Alberta and how we can apply that across the country. So this is an outline, an overview of all of the field operations that we do. Like Aaron said, we have 3 separate sub-teams within the NHP field team, that being the hail sampling team, the UAV team, and the damage survey team. I'll talk about each of those individually. And then we also have a couple networks that help us to document hail, those being the HailPad network and our distrometer network, which I'll talk about as well. One thing we often get asked is what does a mission day look like? What does a day look like for an intern on the NHP field team? So this is a typical mission day. So mission is when we actually go out and chase those hailstorms and we're intercepting. This doesn't happen every day. I'd say once or twice a week for most of the summer is when we're out doing missions. But this is obviously, as a field intern, this is your primary goal and the most exciting part of it. So we start every morning with a weather brief from our team of meteorologists. They talk about the weather, even if it's going to be sunny and 30 today, no hail. But if there is going to be hail, then we talk about where it's going to be, what characteristics, how we can chase the storm effectively. And then we prepare our equipment and load the vehicles. And if you've ever been storm chasing, you know that it's a lot of sitting around and waiting for something to happen. So we do a lot of that. And then finally, when we have a storm, we intercept the storm based on our standard operating procedures. We gather the data, and a lot of times what we're left with is a nice bag of hail like this that we keep frozen, we bring back to base, and then we can study later. And sometimes we collect 20 bags of hail, sometimes we get no bags of hail. It's very dynamic that way. So speaking of collecting hail, the first team is the hail sampling team. The main goal of this team is to go right in behind those hailstorms and collect the hail that's on the ground that's been left by the hailstorm. We call that the hail swath. That's the hail that's in behind the storm. And this is really important because it allows us to validate a whole bunch of different models that we have on hailstone size, relating radar data to hailfall, that sort of thing. So actually collecting these hailstones without any melting is important for that. And then this team also can measure the dimensions, how large that hail swath is, just by driving through it and dropping points. And this is, the main, one of our main missions when we're out there is to collect the hailstones in from behind the storm. An example of this that you may have heard of by now is August 1st, 2022. This was the first year that the NHP field team was out, and they found this hailstone, which turned out to be Canada's largest hailstone on record. It was 12.3 centimeters in the largest diameter there. And there's essentially a radar overview of where the storm tracked. And then the black line is how the team sort of went in behind and collected the hail there. So lots of hail was collected. Eventually the storm actually crossed Highway 2 in Alberta, which is the main north-south highway, hit a bunch of cars, did a whole bunch of damage. But we were left with very large hailstones, which is one of the goals, is to collect some large hail because it's the most damaging kind, obviously. And then once we've collected this hail, we do need to process it. We need to actually kind of extract the data from it. So based in Olds, we have a cold room, which is just a freezer in a bar. So there's beer and stuff all around you, but we set up a table here, and our interns go and sit in the cold room for up to a few hours on end with all your gear bundled up, and you take every single hailstone that we've captured and you measure all 3 axes, you weigh it, take a picture of it like this. That way we have an entire database of all the hailstones that we've ever collected and all the dimensions of them. We've measured about over 3,000 now, but I think our collection is upwards close to 5,000 hailstones, which is really great. There's only one collection, I think, that's larger than that I know of, and that's in the US, but they're at 7,500, so we're getting there. So yeah, this is a really important data set of ours, and our interns do all of this, from capturing the hailstones to measuring them, that sort of thing. The next team is the UAV team, also a chase team, goes in behind the storm, works really closely with the hail sampling team, and the goals of them are threefold. So we use drones, firstly, to estimate a hail size distribution, so the distribution of hail sizes that are in from behind the storm. We can also use our specialized drone that I'll show you in a minute, that collects multispectral and thermal imagery. We can see how crops are recovering after they've been impacted by hail. And then they can also fairly easily determine the extent of the hail swath, since they're doing it in the sky. We don't have to follow a road. You can do it that way. These are the two main drones that we use for doing this. DJI Mavic 3 Enterprise. It's kind of our workhorse drone. We use it for surveys and such. And then we have a more specialized, larger drone, the DJI M300, that has the multispectral and thermal camera that we use for crop recovery. Here's some pictures of hail taken by the drones. This is our hail size distribution method. So if we're able to fly the drone really close to the ground when there's hail that's visible on a high contrasting background like this, you can then use a machine learning model to pick out all the individual stones, and it'll tell you the size of each stone and the distribution of sizes that was there. So these are some examples just from 2025 of the team doing that. So you can see varying amounts of hail, varying sizes, that sort of thing. And then one of the transect examples, or the examples of how we estimate the size of the hail swath, is just by flying the drone in a very long pattern, a very long path. And like Aaron was saying, if we do that over a long area and take a whole bunch of pictures and stitch them all together, then we get one big picture. So here's an example. That skinny line in the middle, you can see on this side, it looks like winter. That's all hail that was on the ground, just tons of hail. And then on the other side, it's green summer. So this is the boundary of that hail swath. And we can do that to get the true size of it. And then the last goal of the UAV team is this estimating how crops are recovering. So this field here was impacted by a hailstorm. It's canola. Canola has a very bright yellow flower. You can see on the far end that it's still flowering. It's very bright yellow. So that area wasn't touched by the hailstorm, but closer to us, this crop was impacted by the hailstorm and was damaged. So it gives us a good chance, if we fly right along it, then we get a good gradient of the crop and how it's recovering. And if we repeat that, usually every week, so we started a day after the hailstorm, then we came back a week later, 2 weeks, 3 weeks later, we can see how the crop is recovering from that hail. And this is just visible imagery, but like I said, we have multispectral imagery, so we can get things like NDVI and that sort of thing on the crops. So that's a good example of that. That was this last year as well. And lastly, that takes me to the damage survey team. Like Aaron said, this is one of 3 multi-hazard teams that are across Canada. So we cover all 3 hazards, but mainly we're doing damaging hail events. And so the team will go, the Goldilocks data set is an event which our chase teams went on. They collected the hail. We've got drone data from it. We've got so much data, and it happened to impact something. that the damage survey team can then go and assess the damage, so that we know what the hail size was, we know the characteristics, we know how the crops were impacted, and we know how the built environment was impacted. That's like our complete data set. So that's one of the goals, but the damage survey team does any damaging hail event or wind event in that area that Aaron showed. And then sometimes they also come on the missions with us as well, and act as a second hail collection team, and they collect the hail as directed by the first hail collection team. A couple notable examples of what our damage survey team did last year and the year before is obviously the 2024 Calgary hailstorm. That was a huge damage survey effort. A very large area affected by pretty large hail, 50 millimeters, 5 centimeter hail. We estimated 97,000 residences were impacted in this storm. A good chunk of the north end of the city. And so the challenge was, how do we survey this entire area with high detail, high resolution? And we ended up taking 5 days, 3 separate teams to survey this event in its entirety. And we ended up with a map like this, where the black is where the worst damage was, and it goes this way. And then another event, very, very not as significant as the 2024 event, but the 2025 Calgary hailstorm as well, impacted a much smaller area and was less severe. But again, 30 to 45 millimeter hail, 7,600 residents affected, so much less, but our team covered it in depth as well. And there's a map with the same color scale. You can see that it's very much less severe. Okay, so that's the teams in general. Our interns help with all of that, make up the main people on all those teams. We also have observational networks that our NHP field team helps to maintain. So a HailPad network and the Hail Distrometer network. There's a map of both of the networks put together. The green points in the city of Calgary are where our distrometers are. And then we also have some to the north of the city I'll talk about. And then the blue points are where our HailPad network is located. So we have a pretty good coverage between Calgary and Red Deer, where we tend to see lots of big hail events. So a HailPad is a very simple piece of technology. It's a 2 foot by 2 foot piece of foam, and we mount them on a fence post like this, and we do it in a north-south line here, parallel to the Rocky Mountains. So when you get storms that come off the terrain, they'll hopefully impact some areas on this network. And when the hail hits the foam, it leaves a dent. You can kind of see it in the top right image there. And the dent that's left, we can then measure that, and then we know how big the hail was that hit it. Very simple, very rudimentary, has been used extensively since the 70s. It works pretty well still. And one of our previous but also still current research interns has been developing a better way to analyze these hail pads. So previously we'd have to measure each of those dents individually by hand with a set of calipers or a ruler, and it's very tedious. Some of these hail pads can have hundreds of dents on them, and as small as 10 millimeters. So what they've done was make an automated method to take the 3D scan of these hail pads that creates a depth map that can then pick out each individual dent and the size of it, and process the hail pad for us. And it has a good agreement with on the same hail pad with some people who've done it manually, even in some cases finding dents that they didn't find. And this is going to save us a huge amount of time, and is a really great project, and is currently, there's a paper in review led by this intern as well. So hopefully you'll be able to read that soon. And these are the kinds of things that our research interns are contributing to. And yeah, I wanted to highlight that. And that's mainly it for the NHP section. I'm going to roll right into the NMP, and then we can have questions on the both after that. Since we're on the topic of hail monitoring networks, we can roll over to the Northern Mesonet project. So like I mentioned, there are a set of hail distrometer stations located between Calgary and Red Deer. These are what we call the NMP Hailstorm Network. We have 21 stations in the city of Calgary, and then 8 stations that are east of the Rocky Mountain foothills that give us pretty good coverage there. in the city, most of our stations are at city-owned sites, and they provide us good coverage of the entire city, the residential and commercial areas within Calgary, so that we know if there's a hailstorm that comes through, which we've seen in 2024 and 2025, it's both happened every year and will probably continue to happen. We can get good data on the hail size, how much hail there was, the environmental parameters as well, to better study these events and to understand how frequently they're occurring. The station themselves are comprised of two different devices. Firstly, the Atmos 41, which is an all-in-one weather station. This gives us our environmental parameters like precipitation, lightning, wind data, temperature, humidity, pretty standard stuff. And then the more specialized sensor is the hail flow sensor, which when the station's impacted by hail, this tells us how many hits of hail, the size of the hail. So this is important for the usability of the hail portion. And the stations are run on solar power, as the giant solar panel there, and are cellular, so we can essentially place them anywhere, and they're fully mobile. The only issue is that to maintain these networks is a lot of money, it's a lot of time, and it requires a lot of people. So one of the roles of the NHP field team during the summer is to help maintain this network, because we have so many stations, there's going to be one with some issues at some point during the summer, so we help to maintain that. And there's Mark in April 2024 when it snowed a bunch as Connell and Mark were out doing maintenance on them, the yearly maintenance. So you never know where you're going to go with these stations. That's kind of the takeaway. So that's one main avenue that the NP has been working on since it started in 2024. The second one that you may have heard of is the Canadian Mesonet portal. If you haven't heard of this, I'd highly recommend you checking it out. It's just a free-to-use website. You can use the QR code, you can Google it. The URL is meso.cssl.ca. And I'll go through here a little brief tutorial. So the idea here is that this is a weather station viewer that brings together many, many, many different networks of weather stations across Canada. As you zoom in, you see our traditional weather station plot with the wind barbs, temperature, and dew point. And then on the right side, you get a graph, time series graph of any variable you want to see from those weather stations. So it's really helpful for forecasting, for nowcasting. You can see the whole country. And the idea here is that there are many different operators of weather stations across the country, but they've never before been brought together in one spot. You can see how many stations, each of those dots are stations. You can see how many stations are available across the country. And now they're all in one place that we can access them and their data. There's historical features now that goes back to November of 2024. And there's also weather radar, geostationary satellite, weather alerts, whole bunch of stuff. It's becoming the one-stop shop for your weather needs, observational data. So I highly recommend check it out. And if you have any questions, you can ask Connell or me, but mostly Connell. Okay, so that is it for the overview of the CSSL and the projects. I'll pause briefly. Any questions on the NHP or NMP before we go into the internships themselves? All good? Okay. So we'll talk about the internships and then I'll hand it over to Connell for the Enderlin stuff. This is kind of maybe the main reason some of you are here. So our CSSL internships in 2026 look a lot like they did last year. To be eligible for the internships, you must be a Canadian citizen, international student, or permanent resident, and be currently registered in an undergraduate university or college program at a Canadian institution. And you must be still enrolled in a program in the following September, so September 2026 in this case. The dates for the internship this year are from May 4th to August 28th, 2026. We expect you to be available for this period. Like last year, we're giving a week of vacation that you can take essentially any point during that time. So maybe not the first week or first couple of weeks or the last week, because that's when we do training and the wrap up. But in between then, you can take that week off. But other than that, we expect you to be available to be working. The compensation is $10,000. And like we've been alluding to, there are 3 different types of internships that I'll talk about. So we have our 2 field internships that are specific to 2 projects under the CSSL. All of our interns are CSSL interns, but if you want to do the tornado field internship, then you're under the Northern Tornadoes Project, and that's the post-event damage survey for the wind damage events. The hail field internship is under the NHP. That's the hailstorm chasing. And then our research internship covers all 3 of the projects. You can do a project that involves tornadoes, hail, anything under the Mesonet portal. So anything that the CSSL works on is fair game for a research project as with a research internship. And we'll talk about that. So the first one that we'll talk about is the tornado field internship, like Aaron talked about. This is doing your wind damage surveys. The location is in London. We do expect you to be in London. The reason for that is that the team leaves from London. It's easiest if you're there. And when you're not surveying, you'll be given a task or a project, a small research project that you complete in person at our offices in London. So
I will say we do need to update this slide because there is an option for Winnipeg as well.
True.
This one.
Yes, yeah. So yeah, mention that if you're in Winnipeg.
Especially those online.
Yeah, especially if you're at the U of M. Yeah, that is important. But yeah, if you're with the London team, we expect you to be in London. Your main responsibility is to go to any wind damage service or wind damage and survey the event. You're contributing to the rating, the classification, the research that's done on this. And this internship is good for anyone who likes to travel, likes to see new places, and is okay doing so, I'd say, on a short notice time frame. Both of our field internships, the schedule is very dynamic. Obviously, we go after the weathers, and I think we know as well as anyone else, it's hard to predict the weather as much as we try. So if you're okay with that, that's the main, you'd be good suited for a field internship. And yeah, if you survey on the weekends as well, because that often happens, we'll give you days during the week to make up for that. So you're not going to be working 7 days a week, 24 hours all the time. You will be given like some time off, but it's not going to be necessarily Saturday and Sunday. That applies for both field internships. Anything you wanted to add there?
No, that's pretty good.
Okay.
Thank you.
The next field internship is the hail field internship. Like what I was talking about with our 3 separate teams. The location for this is in Olds, Alberta. Unlike the London internship, we will pay for your travel. For wherever you are in the country, we'll pay for you to go out to Olds, and we also pay for accommodations there. So the team stays in group accommodations in Olds, and we expect you to stay there with the team. And that's completely covered by the CSSL. You don't have to find your own place in Olds, and you don't have to pay for your own travel out there. Main responsibility of this internship is to intercept hailstorms, chase those hailstorms, collect the data like I was talking about. And similarly, when we're not chasing, you'll be given a small research task that you can work on while you're in Olds. And there's lots of other field work to do, maintaining our hailpad network, distrometer network, that sort of thing. We operate 7 days a week. So similarly, you're not going to necessarily be given weekends off, but you will be given 2 days off per week each week. And like I said, usually 2 times a week is when we're out chasing, but there's some weeks where there'll be nothing. There's some weeks where we might be chasing every single day. But your schedule is always fixed, so you'll only be 5 days a week maximum. Yeah, again, if you're okay with that short notice, you like exploring, you like seeing storms, you like being outside, working outdoors, these field internships are the geared towards those kind of people. And lastly, our CSSL research internship. This one is also based in London. We expect you to be in London so you can collaborate, work at our offices, work with our scientists. And your main responsibility will be to work on your research project. You'll develop the methodology, do the analyses, and present your findings to the rest of the CSSL at the end of the summer. This is more of a typical 9 to 5 internship, Monday to Friday sort of thing, that you'll be working at the office and you can choose something that you might be interested in. This slide has a list of potential projects, but this is not by any means exhaustive. If you're interested in something that the CSSL works on or might want to work on, I'd encourage you to suggest it and think about what you might want to work on. This is also on our website if you want to think about that. But this is geared for people who might be interested in grad school or a thesis in their 4th year, interested in doing research, going into academia. This is a good opportunity for that.
That list is online too, so don't feel like you have to.
Yeah, you don't have to
memorize it right now.
memorize or take a picture or anything. How to apply. So if you scan the QR code or go to the URL, you can also just Google CSSL internships or go to uwo.ca/CSSL. There's an internship tab. And you can hit the apply. You'll be going to external students because you're not Western students. And then you'll select the Canadian Severe Storms Lab internships. You'll fill out this information, your school, your program, your year, upload a transcript, if possible, to include your fall grades. That's preferable as well. And your CV as well, upload. Pretty standard stuff. And then it will give you the option for which internship you'd like to apply for. If you're interested in just one, you can just select the one. If you're interested in multiple internships, you can select multiple. And if you select more than one, a little pop-up will come on the right side that tells you which internship would be your first choice. And if you select all 3, it'll be the same which one would be your second choice. And then it's just a drop down. You choose which your first choice and second choice, just so that we know how to match you that way. We will consider you for multiple internships if you select multiple internships. So just select what you're interested in if you're interested in both and make your preferences. Yeah, that's why that option's there. There's a brief statement for why you'd like to participate. And then similarly, we have 2 questions at the bottom. Do you have a Canadian driver's license? You can select what applies to you there. That's especially important, well, really only important for our field internships because we do a lot of driving, as you can imagine. It's important, not a requirement of the internship by any means to have a driver's license, but it's helpful for us to know when we're hiring. And similarly, mostly important for the NTP field internship is your level of fluency in French. There are a lot of events in Quebec that the team goes to, and it's helpful. Again, not a requirement of the job, but helpful to know applicants' level of French. Yeah. And that is everything. The last thing I'll say, there's our email. If you have any questions, you can email us. We have an FAQ section on the website. I encourage you to check that out. It covers many of the questions you might have. And yeah, if you have any questions, we can take them now. Thank you.